All right, geometry kids. In section 1.7, we get into some pretty important and features of geometry that, like, when you think of geometry, this is like some key stuff. So we're going to work on finding the perimeter, circumference, and area of different polygons. So how do you find dimensions of polygons? So we're going to talk about the square, the rectangle, the triangle, and the circle today. So first of all, perimeter is measured, or we call perimeter P, we call area A, and we call circumference C. So in a square, if the side length is S, so let's say we call each side S. So what makes a square is that all the sides are the same. So each side is S units long. So S could be any number. It could be 5, 10, 27, 3. It could be anything. So to find the perimeter, there are 4 sides. So it's 4 times S, or 4 times whatever the side length is. The area is the side length squared. That's how you find the perimeter and area of a square. A rectangle has length and width. So you can see we have L and W. There's an L on the left and W on the bottom. So to find the perimeter of a rectangle, it's 2 times the length plus 2 times the width. And to find the area of a rectangle is just length times width. And this is one that you probably have seen before in math classes dating back to middle school, maybe even in elementary school you might have seen some of this. And then triangle. In a triangle, the sides we'll call ABC, and the base is B. So the base is the side that forms a right angle with the height. So in this one, to find the perimeter, you would do A plus B plus C. Nothing special, just add up the sides. And to find the area, you would do 1/2 times the base times the height. Okay, and then the last shape we're going to talk about is the circle. The circle doesn't have a perimeter. It has what's called the circumference, which is basically the perimeter of a circle. And we use what's called the radius to find these things. The radius is the distance from the center to the outside of the circle. So the circumference is 2 times pi times r. And the area is pi times r squared. Okay, and then below there it just says that pi is the ratio of a circle's circumference to its diameter, which isn't really all that important right now. We're just going to work on using the formulas. So a couple comments here. Finding the circumference of a circle is the same as finding its perimeter, which we already mentioned. Perimeter and circumference are always labeled in units. So like if it's in inches, it'd be inches. Miles is miles. Centimeters is centimeters. Area is always in units squared. What this means is if the measurement is inches, the area will be like 10 inches squared or 14 inches squared. And we have an example down here. So the inbounds portion of a singles tennis court is shown. Find its perimeter and find its area. So the area, we'll start with perimeter. This is a rectangle. So the perimeter is 2 times the length plus 2 times the width. So let's label what is the length, what is the width. So in this one, the length is, we'll call it 78. And the width is 27. And I'll be honest, if you have these flipped, if you call the width 78 and the length is 27, it's going to give you the same answer. So your perimeter equals 2 times 78 plus 2 times 27. So 2 times 78 plus 2 times 27 is 210. And then we label it in feet, because that's the measurement they give us. So 210 feet is the perimeter. That's what it would be if you went all the way around this rectangle. All right, to find the area of a rectangle, area is length times width. So to find the area, it will be 78 times 27. And 78 times 27 is 2,106. And this one is in feet squared. The area is in feet squared. That's what I mean when I said unit squared, that's what I meant. If the unit is feet, area is feet squared. All right, checkpoint. We'll do this one together quickly. From example 1, the width of the inbounds rectangle increases to 36 feet for doubles play. So it goes from 26 feet to 36 feet. So now the rectangle looks like this. It's still 78 feet long, but now it goes to 36 feet wide. So now length is still 78, width is 36. So perimeter is 2L plus 2W. So it's 2 times 78 plus 2 times 36. So 2 times 78 plus 2 times 36 is 228. So the perimeter is 228 feet for a doubles court. The area for a rectangle is still length times width. So the area is 78 times 36. So the area of this one is 2,808 feet squared. 2,808. I don't know why that disappeared. And then down here, just some notes. The radius of a circle is half the diameter. This is completely different, has nothing to do with the problem we just did. And the diameter of a circle is twice the radius. So just know the radius and the diameter are related. If I drew a picture, it would look like this. That's your radius. Your diameter is the whole width across. Okay, in example 2, it says the smallest circle of an Olympic target is 12 centimeters in diameter. Find the approximate circumference and the area of the smallest circle. So what they tell us is that the diameter equals 12 centimeters. Let's start with the equations. The equation for circumference is 2 pi r. And the equation for area is area equals pi r squared. So the one number we have to know is what is the radius. And they don't tell us that. But we do know the diameter is 12. So what that means is the radius is 6. So the radius is 6. That means the circumference is 2 times pi times 6. If you type in your calculator, it'll be about 37.7 centimeters. And the area is pi times 6 squared. Pi times 6 squared is 113.1. And we label this as centimeters squared because area is always squared. Okay, and then we'll do the checkpoint. Find the approximate circumference and area of the circle at the right. So circumference is 2 pi r. Area is pi r squared. So in this one, what is r? R equals 8. So the circumference is 2 times pi times 8. And 2 times pi times 8 is 50.3. And this is meters. See how it says 8 meters? So circumference is 50.3 meters. The area is going to be pi times 8 squared. And pi times 8 squared is 201.1. And this will be meters squared, because area is always squared. Okay, and then example 3 uses a triangle. They tell us that there's vertices of the triangle given at the right. It's already graphed for us. We want to find the approximate perimeter of the triangle. So this can be a little tricky. The first thing we're going to do is count the one we can count. To find the perimeter, we have to find all the sides. How big is this side of the triangle? Well, we can just count our way over. So let me change to a highlighter. This would be 1, 2, 3, 4, 5. So it's 5 blocks wide. We have to find the other two sides. To find those, we have to do the distance formula. So first, let's find KL. KL will be this one. So the distance formula is the square root, okay? And you have to take the x values and subtract them. So the x's are 6 and 3. So it's 6 minus 3 squared. Plus, now you take your y values, 6 and 2. So 6 minus 2 squared. So this would be the square root of 6 minus 3 is 3. So it's 3 squared. 6 minus 2 is 4. So it's 4 squared. So 3 squared is 9. 4 squared is 16. So KL equals the square root of 25. So KL is 5. So that side is 5 as well. Now we got to find JL. JL is right here. So again, we do distance formula. So take the x's, 3 and 1. So 3 minus 1 squared. Plus, now take your y's, 2 and 6. 2 minus 6 squared. So 3 minus 1 is 2, so it's 2 squared. Plus 2 minus 6 is negative 4, so it's negative 4 squared. So 2 squared is 4. Now what is negative 4 squared? If you did negative 4 times negative 4, you will get 16. So this is the square root of 20. And the square root of 20 is 14.5. Actually, whoops, I screwed that. I read the wrong thing. Not 14.5. The square root of 20 is 4.5. So if we take all the sides, KL, JL, and then the one we could count, which would be JK, the perimeter would be 5 plus 4.5 plus 5, which would be 14.5 units. Now that was kind of tricky. There will not be many problems that you'll see like that. But just want to show that we can find the perimeter of a triangle in a graph by doing distance formula. Okay, and then we'll do example 4 and checkpoint. We're going to finish this up, and that'll be all. The base of a triangle is 24 feet. Its area is 216 feet squared. Find the height. So we're talking about area of a triangle. Area of a triangle is 1/2 times base times height. So if we know the base and we know the area, we can plug those in. What's the one thing we don't know? We don't know the height, but we're going to find that. So if we keep going, 1/2 of 24 is 12. So it ends up being 216 equals 12h. If you divide by 12, 216 divided by 12 equals h. And 216 divided by 12 is 18. This would be 18 feet equals the height. And the reason why we pick feet is because that's what was in the problem. It's feet. So sometimes they give you the area and you have to find a height, and that's how we do it. And the checkpoint's the same kind of problem. The area of a triangle is 96 inches squared. The height is 8 inches. Find the length of the base. So the area is 1/2 times base times height. Just so you know, if this were a different shape, like let's say a rectangle, you would put down area equals length times width. But this one tells us it's a triangle. So you plug in the area. We don't know the base, but we do know the height is 8. There's a couple ways you could do this. I think the quickest way, the easiest way would be on the right side. What is 1/2 times 8? And 1/2 times 8 is 4. So you would get 96 equals 4 times b. Divide by 4 to get b equals, and 96 divided by 4 is 24. So the base would be 24 inches. Okay, and that's all we got for you.